Hey guys, so this is our first lesson for PreCalc, and what we're going to do in section 1.1 is everything with linear equations. So linear is line. Everything that we have ever studied with a line, we're going to do it in one section. So we're going to start with slope, and so in true PreCalc form, we're going to get away from this word slope, and we're going to say everything now is a rate of change, okay? So this rate of change, and so what we know is my variable for slope is still going to be m, so my rate of change is still going to be m, and just a little review here, my equation for slope is y2 minus y1 over x2 minus x1. So this slope equation, which is our rate of change equation, is not any different. We're just going to call it a rate of change. And when you think of rate of change, what I want you to do is don't just look at the numbers, but think about this context. So a rate of change, you could say something like 6 miles per gallon. So this would be a rate of change. We have 6 on the top and we have a 1 in the bottom. So miles per gallon, so miles over gallon. So this would be a rate of change, okay? So when we calculate our rate of change, we want to find the slope of this. So I'm just going to go in here. I'm going to say this is my first ordered pair, x1, y1. And here's my second ordered pair, x2, y2. So when I plug this into my equation, I would have y2 minus y1, so 8 minus 4, over x2 minus x1, so 6 minus a negative 3. So when I do the math on this, this becomes 6 plus 3, so 2 negatives here, so I would have 4/9. So another way that we looked at this is we would say sometimes that this is rise, and a lot of teachers would say rise over run, and I like to say rise over right? So the reason I do this is because if this top number is positive, then we're rising, but we're always going to go to the right. So rise over right. Another way that you can look at this is when I have this equation right here, this is my y values, and these are my x values, and what I did was I subtracted these, right? y2 minus y1. So we also look at this is the change in y over the change in x, okay? So I'm going to go back up here, I'm going to modify my equation just a little bit, and I'm going to say change in y over change in x. And so this change in y over change in x, we can always say here that this delta is change. So we're looking at the difference between our y values and the difference between our x values, okay? So when I look at this next one, I'm going to mix it up a little bit. Remember, when we have an ordered pair, it doesn't matter which ordered pair goes first. So I'm just going to say, for example, that I'm going to make this my x2, y2, and this my x1, y1. Order doesn't matter. So when I do the math on this, I would have 5 minus 5 on the top and 3 plus 6 on the bottom. Now, that gives me a 0 on the top. And whenever I have 0 on the top, this is okay. So because it's okay, my value of my slope is 0. Now, when my value of my slope is 0, I have a horizontal line. So my line is going to go horizontally. Whereas this one was a positive number, so my line is always going to go up when you're going from left to right. Okay, let's do this last one. So if I look at this last one, I'm going to make this my y2 point and this my y1 point, only because it gives me a positive number on the top. So 8 minus 4 is 4, and negative 2 plus 2 is 0 on the bottom. Now when I have this 4 divided by 0, this is now undefined. And when I have an undefined slope, what I have is I have a vertical line that's just going to go up and down. So vertical line, L-I-N-E. Okay. Now, you can take any 2 points on a line and you can calculate your slope just like we did up above. But we can also go back to this rise over right, or in this case, my line is going down. So if I find 2 points that cross through your XY coordinate plane right here, if I find I've got a point right here and a point right here. So if I look at going left to right, I always start with my leftmost point. So if I look at this point, I go down 1. So my slope is going to be negative 1 because I go down, and then I go over 1, 2, 3. I'm going to go over 3. So my slope is going to be negative 1/3. I can start at this point and I can go down 1 and over 3, 1, 2, 3, and I see that I cross those points again right at that hash mark. Okay? Now, we just said up here that when we have a horizontal line, we have a slope of 0. So here's my horizontal line, so I know here my slope is 0. But let's look at one more thing here. Because this is a horizontal line, I know that if I go down 1, 2, 3, 4, 5, this point right here, I cross my y-axis at 5. Okay? Now, anywhere I drop a vertical line, I'm going to hit an x value. So because I only hit the y value in one place, the equation of this line is going to be y equals -5. Okay? Now, we have something really similar right here. We cross the x-axis at this point, which is at x equals 2. Anywhere I draw a horizontal line, I'm going to have a y value. So my range on this case is going to be all real numbers because I hit every y value along this axis. Okay? So when I have a vertical line, it's always going to be an x equals. When I have a horizontal line, it's always going to be a y equals. Okay? Now let's go down here and talk about parallel and perpendicular lines. So when we're dealing with slope, parallel lines have slopes that are the same. We can also say that they're equal. Now, we would write this as slope of a parallel line, and that's just these two little lines that are parallel. We can also just say parallel. Sometimes you'll see them written this way, like kind of slanted, but up and down is the correct way to do this. And then perpendicular lines are slopes that have opposite reciprocals. And an opposite reciprocal, so opposite means opposite sign. So this would be from a positive to a negative or a negative to a positive. And reciprocal means we're going to just flip the fraction. And even if I don't have a fraction, so let's just say I had a slope of -2. This is technically when I find the opposite reciprocal. Opposite sign is going to be a positive, but when I flip this fraction, it's now going to be 1/2. Okay, so let's say that I started with a slope of 4. The opposite is going to be negative, and my reciprocal, when I flip this, it's going to be -1/4. Now, I can go the opposite direction too. So if I start with negative, let me start, hold on, I want a whole number, -3. Opposite sign is going to be positive, but when I flip this fraction, I end up with 1/3. Okay? And my sign for perpendicular is this little symbol that gives me 2 right angles. So here I would say that I have a slope that's perpendicular, which forms these 2 right angles. It's an upside down T. Okay? So if we have 2 lines, we want to identify if their slopes are parallel, perpendicular, or neither. So the first thing I'm going to do is for line number 1, I want to find the slope. So I would have 2 minus a -1, so that would be 3. So slope of this would be 3. And then on the bottom I would have -2 minus 0, so -2. So that's my slope of my first line. When I have line 2, I'm going to go opposite on this one. So I'm going to say 2 minus a -4 over 3 minus a -1. So this becomes 2 plus 4 over 3 plus 1. So this gives me 6 over 4. Now, the first thing that I'm going to do on any of these is I'm going to always reduce everything so that I can really compare them the way that they need to be compared. Okay? So here's the slope for my first one. Here's the slope for my second one. So what is this saying? So we want to know if they're parallel. Well, this is -3/2, and this is +3/2. So they are not the same. Remember, parallel slopes have to be the same. They're not the same, so they're not parallel. Perpendicular slopes have opposite reciprocals. This is negative, this is positive. Those are opposite, but reciprocal, this would have to switch. So my opposite reciprocal would be -2 over 3. So because it's not that, this relationship is going to be neither. Okay, now let's talk about what that looks like. So if I had 2 lines that were parallel, so if I have 2 lines that are parallel, my 2 lines are going to look like this, right? If I have 2 lines that are perpendicular, my 2 lines would look like this. Now, it's very rare that we see them look this perfect, right? So here I have a right angle, and here I have a right angle, right? More often, you're going to see them that look like this, right? So these are still right angles. Okay, but in this case that I had up here, so my answer was neither. So what does that look like? So I have one slope that looks like this, and this would be my -3/2 slope. And then I have this one, which is 3/2. So that one could look more like this. And so this would be my +3/2 slope. And so what you see is that this is a big obtuse angle, and this is a little acute angle, and they are not 90-degree angles. So for us to have perpendicular lines, that's why we have this, which forms up here 2 right angles. And since I don't have 2 right angles, then they're neither parallel or perpendicular. Okay? All right, let's keep going. All right, so slope-intercept form. This was the first form of slope that you learned clear back in pre-algebra. And we know that the equation of that is going to be m, and then I'm going to say mx plus b. And I know I'm throwing a lot of colors on here, but mx plus b. So that is the equation that is in slope-intercept form. So we have a slope, which is my m, and we have an intercept, which is the b. So this part right here is my intercept, and this m right here is my slope. All right, and when we use this most often when we're going to graph a line. So, and the reason why we do that is because we have our intercept. Our intercept is always our starting point. So if we look at this first equation, it's in the form y equals mx plus b. And you're like, well, hold on, there's nothing there, but that's correct. There's nothing there. It's the same as saying plus 0, right? So my intercept here is 0, and my slope here is just the m, not the x. The x tells us what our multiplier is. It's just the m. So my slope here is a -2. When we graph this, we can also say -2/1. Okay, so we always start here. So this is our starting point. We start at 0, and this tells us that we're going to go down 2 and right 1. So down, negative, always right. So down 2, right 1. Now, I'm going to take this -2/1, and this I can also make a negative slope by saying 2/-1. So this would tell me up to left 1. So up to left 1, and this would just continue to draw our line. Okay, so here's what my line looks like. Now, I'm going to cover one more thing here because I think it's super important. When we have this b equals 0, we know that this point right here goes through the origin. And when we have a linear equation that goes through the origin, we call this a direct variation. So sometimes you'll see something that says it's a direct variation. That means it's always going to go through that ordered pair 0, 0 right in the center. Okay, so this next one, I have mx plus b. So here, we don't have anything connected to the x, so my slope here is an implied 1, because really we do. If we didn't have anything there, then we wouldn't even have an x. And then my b value here is going to be -2, so the b is everything that's on the back side. Okay, so with this one, I'm going to start at -2, and then my slope is 1, which is the same as 1/1. So up 1/1. So my line looks like this. Okay? All right, next one. Y equals 3. So we have this equation, y equals mx plus b. And you're like, okay, well that doesn't work because we don't have an x. But that's correct. We don't have an x. So this is like saying x equals 0. So if my slope equals 0, so let me change this actually. Let me say m equals 0. If my slope equals 0, then that part goes away. Well, then that's what I have here. So what I have is I have a horizontal line. So here, my slope is 0, and my intercept is 3. That's this part right here. So just y equals 3. So at 3, my line looks like this. All right? Now with this next one, I'm not in the form y equals mx plus b. Now, because I have a 10 over here, and 3 does not evenly go into 10, it's not a factor of 10, then the easiest way to solve this problem is to put it in slope-intercept form. So I'm going to move the x over, so 2y equals negative 3x plus 10. And I'm putting the x term first because I want it in the form mx plus b. So I'm just going to keep that there. And then I divide everything by 2, so negative 3/2 x plus 5. And now I have what I have. So negative 3 over 2. This gives me my slope, and my intercept happens at 5. So I start at 5, 1, 2, 3, 4, 5. And then I'm going to go down 3, right 2. Down 3, right 2. And that's what this line is going to look like. Something like that. Now, I don't have an example of this, but I'm going to show you just a little change in this. Let me change my equation up here, and I'm going to just write this down here, and I'm going to say my equation is going to be 5x plus 2y equals 10. Okay, so if I have this equation, 5 is a multiple of 10 and 2 is a multiple of 10, so I can take this problem and I can solve this by intercepts. And oh my goodness, my spelling's awful. Intercepts. All right, so I don't have a grid mark because this just kind of came to me, but when I want to solve for my y-intercept, that means my x value is 0. So when my x value is 0, if I solve this, I know that this is y equals 5. So 1, 2, 3, 4, 5. So I would have this point right here at y equals 5. When I want to solve my x-intercept, that's this one, then that means y equals 0. So when y equals 0, then my x-intercept would be 2. So my x-intercept happens right here at 2. Well, we really want 3 lines or 3 points to have a nice straight line, but in this case, I have this point here and I have this point here, and my line would look something like that because it would go through those 2 intercepts. Okay, so I didn't solve this one up here this way because that wouldn't have given me a nice number. So if I would have found the intercept for this, I would have 3x equals 10. So x equals 10 over 3, which is 3 1/3. And you can graph that. You can totally graph that, but it's just not a nice, pretty number on your graph. Okay? All right, let's keep going. And let's look at, intercepts. Probably should have looked at this before I start talking. So x-intercepts. So to find my x-intercept, this happens when y equals 0. So when y equals 0, what you end up with this ordered pair that is x, 0. And to find my y-intercept, that's when x equals 0, and I end up with this ordered pair that is 0, y. Okay? Now, sometimes people are like, well, how do you know which one equals 0? Well, think about it. If you're solving for x, then you need to make it equal x. We don't want to get rid of the x if we're trying to find our x-intercept. If you're trying to find your y-intercept, you don't want to get rid of the y because you want to know what does y equal. So if I go down here, if I'm solving for my x-intercept, that means the y value equals 0. So if the y value equals 0, all I have here is just x equals 4. So my intercept would be 4, 0. If I'm solving for my y-intercept, that means x equals 0. So if x equals 0, I have 2y equals 4, and then I divide this out, so y equals negative 2. So my y-intercept happens at 0, negative 2. And we write these as ordered pairs, right? So what this would look like is if I was to graph this, I would have my y-intercept right here at 0, negative 2, and my x-intercept right here at 0, 4. So I know that I have this line that's going to have a positive slope that's going to look like that. Okay? So let's do this one. So I want to find the x-intercept. That means y equals 0. So I have 3x equals negative 15. So x equals negative 5. So I have negative 5, 0. When I want to solve my y-intercept, I would have 5y equals negative 15, so y equals negative 3. So this one would be 0, negative 3. So what does this look like if I was going to graph it? 1, 2, 3, 4, 5, negative 5, negative 3. So this line would actually have a negative slope. Okay? All right, so just to kind of recap a little bit, a slope-intercept form, we use y equals mx plus b. And see, I'm not really sure what our uses here are for graphing. And to find the y-intercept, I'm going to say, our starting point. Okay. Now, we also have this format called point slope. So if I have a point, and I'm going to say I have a point that's x1, y1, and I have a slope, then my formula for this guy is y minus y1 equals m times x minus x1. And we use this when we're writing equations. And we have a point and a slope. And actually, in this case, a lot of times we'll write the equation, and then after we write the equation, we put it back into slope-intercept form so that we can graph it. All right, so let's do a simple one first. It says write an equation of a line. So equation of a line, you should think point slope. Through a point, I have a point, x1, y1, and a slope of 4. So I'm literally just going to plug this in. And I'm going to say y minus 6 equals 4. That's my slope. X minus a negative, so plus 1. Now this would be in point slope form. But I'm going to keep going. And I'm going to go ahead and distribute this out and simplify it. So I would have y minus 6 equals 4x plus 4. I move the 6 over, and I would have y equals 4x plus 10. And this is now in slope-intercept form. So be careful of what form it asks you to solve in. So a lot of times, if you're given multiple points, when you write it in point slope form, you could have 2 different answers. But always in slope-intercept form, you're going to have one answer. Okay, so let's look at this guy now. So it says write an equation of a line. All right, so I have 2 points. So let's talk about everything that we could do with this. So what I have right now are 2 points. I have this point, which is negative 1, 1, and I have this point, which is 2, 0. So with 2 points, here are the different things I can do. I can find the slope. We just did that a minute ago, y2 minus y1, right? With 2 points, I can find the equation of the line. Now, I could go in and I could calculate this algebraically, but because of this graph, I'm just going to say my slope is going to go down 1, and then 1, 2, 3 over 3. So my slope here is going to be negative 1/3. And all I did is just pull this off the graph. I didn't do any math on that. Now, I can use either point. So I'm going to use this point because I like to use things that have 0 in them. So I'm going to say y minus 0 equals negative 1/3 x minus 2. So that could be my equation. Now, I could have used this one and have y minus 1 equals negative 1/3 x plus 1. Okay, now this is what I said a minute ago. If I look at these two, the answers they don't look the same. But if I take it all the way into slope-intercept form, you're going to see that they are. So if I distribute this 1/3 through here, I have negative 1/3 x plus 2/3. And then the 0 cancels out. If I look at it over here, I would have y minus 1 equals negative 1/3 minus 1/3. So when I move this 1 over, I add 1 to this side. That's the same as saying I'm going to add 3 over 3 because I have a fraction. I have to have a common denominator. And I have y equals, I forgot my x here, negative 1/3 x plus 2/3. So these two answers, when I get them into slope-intercept form, are the same. So that's why it doesn't matter what point you use, but as you can see just from the math, it's always easiest if one of your points is, if you can use a point with a 0, I would always use a point with a 0. Okay? All right, let's keep going here. So write an equation of a line that passes through 2 points. All right, so here's what I have. Looking at this, I'm going to say this is x2, y2, and this is x1, y1. All right, so first thing I have to do is calculate the slope. I don't have a slope. For me to use point slope formula, I need a slope. So my slope is going to be 10 plus 2, which is 12, 2 minus 5, which is negative 3. So my slope here is negative 4. All right, so again, I can use either point. It doesn't matter. I'm going to use this point only because they're both positive numbers. And I'm going to say y minus 10 equals negative 4, x minus 2. So when I do the math on this, I have y equals negative 4x plus 8 plus 10. So negative 4 times negative 2 is this positive 8. I move this 10 to the other side. So y equals negative 4x plus 18. Okay, and I know I'm going through this pretty quick, but you did this in pre-algebra, you did this in algebra 1, you did this in algebra 2, so this should really be review. If not, please come see me, because we're doing everything in one day. Okay, write the equation of the line shown. So I have 2 points here. This one's 1, 1, and this one is 0, negative 2. So if I look at my slope on this, I go up 1, 2, 3, and over 1. So my slope, I went up 3 and right 1. So my value of m is just 3. It is not 3 over 1, right? It's just 3. So my equation of my line, I'm going to use this one because I have a 0. So y plus 2 equals 3 times x minus 0. And when I do the math on that, I end up with 3x minus 2. Now, let me show you an even easier way to solve that. We know that this point right here is my b value. And this is my b value because it is the y-intercept. The y-intercept is where my line hits the y-axis. It's not always where it crosses the y-axis. We're going to do some things with quadratics this year where it's not necessarily going to cross the cross the axis. But in this case, we do cross through, but it's where we hit the y-axis. This is my intercept. So if I know that this is my intercept and I see that my slope is up 3 over 1, then I could have just written my equation like this right here. So this is mx plus b. I have my y-intercept and I have my slope up 3 over 1. So you see, if you go through, and let's say you didn't identify it, and you go all the way through here and you write it in point slope form, you're going to end up with the same answer. Okay, this one is just way faster if you identify this as your y-intercept, as your b value. Okay? All right, so write the equation that passes through this point. So here's my point, x1, y1, and is parallel to this equation. So if this is parallel, then my parallel slope is the same slope, so my slope is going to be negative 4. Okay, so this means that my equation is going to be y minus 3 equals negative 4 x plus 2. And I'm just going to leave it like this. What I'm testing right here is just that you can find the parallel perpendicular slope. We know at this point that we can keep going and put it into a form that we can graph, but this equation's fine right here. Okay? All right, perpendicular slope. So my perpendicular slope is my opposite reciprocal. So if I start with negative 4, my opposite sign's positive, and when I flip this guy, I end up with 1/4. So here my equation is y minus 3 equals a positive 1/3 x plus 2. Oh, I said 1/3, 1/4. Y minus 3, that's my y value, equals positive 1/4 x minus 2. Okay? All right, next one. Write an equation of a line that passes through these 2 points. So I have a point, I need a slope. So my slope value here is going to be 8 plus 2, and then I have 3 minus 3. So this gives me 10 over 0. So I have an undefined slope. So if I have an undefined slope, I know I have a vertical line. If I have a vertical line, this means it has to hit the x-axis. And if I look here, it's going to hit the x-axis at x equals 3. And another way that you can look at this is if I have this point right here at negative 3, one of my lines is up here at 8, so I have a point right here, and I have this other point right here at negative 2. So my line to go through both of those has to look like this. It has to go through this point 3, 8, and it has to go through this point 3, negative 2. Okay? So, write an equation of a line that passes through this, and this is what I'm noticing right away. So if I look at my slope value, I have -2 plus 2, so I know my slope, looking at just my y values, is going to be 0. And if my slope is 0, I'm going to have a horizontal line. It's going to go this direction. So looking at the same thing that we looked at just a minute ago, if I have this point at 3, -2, I'm going to have a point right here. And 5, -2, I'm going to have a point that's right here. So my line, we just said, slope of 0, I have this horizontal line, and it happens when y equals -2. Okay? All right, 2 more, almost finished. So an equation of a line that has an x-intercept of 5 and passes through the point of 2, 3. So an x-intercept of 5, that is not my y-intercept. This is the point that I have. This is my x-intercept. So what I have here is I don't have a slope, I don't have an intercept, but I do have 2 points. So here's my first point, and this point is really 5, 0. So I have this point 5, 0, and I'm going to have a point 2, 3. So right away, I bet I'm going to have a negative slope, and I can go through either one of these 2 lines. Okay? So to find my slope, I'm going to make this my second point, so that I have a positive number on top. So 3 minus 0 is 3, and 2 minus 5 is -3. So my slope here is going to be -1. And then again, it doesn't matter, but I like points with 0, so y minus 0 equals -1 x minus 2. Now, I'm going to simplify this out because I don't like this -1 right here, and I want to get rid of the 0. So what this is going to look like is y equals -x plus 2. When I distribute this -x here, I don't say -1x. The -1 is going to drop out. So it's going to be -x, and then negative times negative is +2. Okay? All right, last one. So I have a point, and it says it's parallel to the x-axis. So let's look at this and see what we have. I'm going to draw this out here. So I have this point 1, 2, 3, 4, 1, 2, 3, 4, 5. I have this point that's right here. And what I want is a line that's parallel to the x-axis. So here's my x-axis right here. And I want a line that's going to go through this point, but it's parallel. So if it's parallel, it has to have the same slope. Well, the same slope of the x-axis, this is a horizontal line, and a horizontal line, then my slope on a horizontal line is 0. So that means that my line that I'm looking for is going to be this one, right? And so if this also has a slope of 0, and I know I have a horizontal line, I'm going to cross through this point right here, so my equation is just y equals 5. Okay, so sometimes it helps if you kind of sketch out what you're looking for, because when you see this, you're like, okay, if I want something that is parallel to that, it's going to have the same slope. Now let me change this up. Let's say that I want to find something that is perpendicular to the x-axis. Well, that line is going to be this one, right? So now what I have is I have these 2 right angles that go through this point, right? So this one is going to be an x equals. So if it's perpendicular, I'm going to say x equals 5. This was what my equation would be if it would be perpendicular. Okay? So that was a lot of stuff that we went through with lines. So come see me if you're struggling.